Okay, so the last topic in 2.2 that we need to talk about is something called piecewise functions. And so this is essentially a way to get two or more formulas attached to one function. So instead of just having a function that's like f of x equals 3x cubed minus 2x plus 5 for all of the different x values, for all the values in the domain, you could have a function that has a couple different formulas sort of split up and assigned to different x's. So this is, let's get that in words. So multiple formulas for the same function. And I think the best way to sort of talk about this is really just to sort of start with an example. So I'm going to sort of list and sort of write out what one of these would look like, and then we'll kind of go through the details of how this works sort of with this example, and then of course we'll do another afterwards. So f of x, our kind of classic function notation. What we're going to do if we have multiple formulas is we'll use sort of a bracket like this, kind of a big bracket, and that gives us space to do sort of two or more different like formula definitions. So I'll do pretty simple stuff. Let's just do something like x squared plus 4 is one of our examples, and then let's do, negative 3x plus 1 or something is our second formula. So by itself, if we don't do anything else to this, it kind of obviously gives us the issue that if I try to put in a particular x value, I mean, I guess in theory you would need to put it in to sort of here and to here would pretty obviously get you two different results, two different kind of output values. And kind of by definition, right from the very beginning, we said to be a function you have to only have one output for all of your different x like inputs. So that's definitely not going to work. So what we need to do is define which x values go with which of these formulas. And so what I'll do is, let's say we're going to make the split here at, I don't know, how about x is positive 2? So let's say in the top one, let's do all of our x values that are greater than or equal to positive 2. So this is the formula, right? And these are the different x's that are associated with it. So if we have all the x's that are greater than or equal to positive 2, that must mean kind of by default down here, we're going to have all the different x's that are strictly less than positive 2. So the equal than, right, equal than 2 is specifically defined to go into the top formula. Anything that's less than 2, right, including things that get close to 2 but don't hit it, 1.95, 1.995, right, 1.999, that's not repeating. All those different numbers are going to be less than 2, and they're going to go into this second formula. So this is, right, kind of on top, which x's, and then this is our formula. And so what this means, right, is if I try to sort of evaluate this at a particular like x coordinate, particular x value, so if I say find, right, f of negative 2, right, so this is for us x equals negative 2. So the first thing we need to do is just sort of decide, okay, which of these two formulas is this going to go into? Well, it depends on how big our x value is, right? The sort of dividing line here is positive 2. So if we're above positive 2 or equal to positive 2, we're going to use the top formula here. If we're less than positive 2, in this case, right, negative 2 is definitely less than 2. So that means we're going to use the bottom formula. We're going to use that negative 3x plus 1. That's going to be the form that we sub into. So this is going to be negative 3 times our x plus 1. The x we use, of course, is just the number that we're subbing in, right, is the negative 2. So negative 3, right, times negative 2. If I evaluate this, this is just going to get me a positive 6 plus 1. And then my result here is just going to be positive 7. So I'm picking an x, right? We're essentially picking these at random. So I pick sort of negative 2 right? This is a value that's less than 2, so it goes into this bottom formula. Shift this up. We'll keep this formula in our frame. If we do a couple more x's, right? If I did something like f of positive 1. So in this case, right, my x is positive 1. Positive 1 is still less than 2, so I'm still going to use that bottom formula, right? As long as my x here is less than 2, I'm going to use the bottom one. So we'll just repeat that again. So negative 3 times my positive 1 in parentheses, and then we're going to have a plus 1 on the end. So we'll sub our 1 in. What the result is, right, negative 3 times 1 is negative 3 plus 1. So our result here is minus 2. You can kind of imagine to a certain extent, right, this second line, this negative 3x plus 1, this is a linear function, right? It's in our mx plus b kind of form. Negative 3 would be the slope. Positive 1 would be our like y-intercept. So you could kind of imagine what that graph would start to look like. I'll hit our sort of like pivot point right on the nose. If we do x is 2, in this case, right, so now we're starting to shift into that top formula, right? So in this case, x equals 2, that's going to go into our top formula. That's going into x squared plus 4, right? Because if the x, as soon as it hits 2 or is any larger than 2, we're going to use this formula up here. So now that's going to be, right, the x value squared plus 4. Right, so quantity squared, we'll throw that 2 in here. 2 goes in. 2 squared is going to be 4, plus the 4 next to it. It's going to send us up to 8. Okey-doke. And then you can imagine, right, if I start to get any larger than 2, right, if I just sort of shift up, we'll just sort of pick at random, right? Well, I guess we're sort of moving by 2's a little bit. We jumped over 0, but if I did something like x equals 4. 4 obviously greater than or equal to 2, so we're going into our top formula, right? So again, using this x squared plus 4, because the x value we're subbing in, 4 in this case is greater than or equal to 2. So we'll square it. Quantity squared plus 4. Our x value is 4. So we'll replace that in our formula. 4 squared for us would be a positive 16 plus the 4 here. It's going to spit us out at 20. So I'm not breaking any of my rules as far as whether or not I am a function here, right? I'm not doubling up on any of these like defined values, right? Each of these x's is still only giving me like one value at a time. So that aspect of being a function is totally fine. We're definitely hitting that. And we're doing it making sure there's just no overlap between these like defined values. That's the basics of it. We'll run another example here in the next video.